Today we're in the final day of section 2.1, and again we're going to kind of go through a few random final topics in this section before we finish the section of 2.1 with our complex numbers. So the first one we're going to talk about is using the quadratic formula to solve a quadratic trinomial. Quadratic formula is something that you had to memorize last year, so again I expect you to memorize this formula. You should already know this formula. So if you don't know it, you definitely need to write it down. And remember that a is coming from your x squared term, the b is coming from your x, and the c is your constant. And in order to use quadratic formula, you have to be equal to 0. So for our first example, the problem wants you to solve 3x squared minus 2x plus 4. So notice I'm in standard form, I'm equal to 0. When you look at this, if you try to factor, if I multiply a and c, I get 12, a positive 12. And notice there's no combination that's going to multiply to be 12 and add to be a negative 2. So that means we definitely have to use quadratic formula for this. So we know our a, b, and c, and the formula starts off of negative b. Yes, you could skip that step and just write positive 2. I'm just going to write everything out. I'll have negative 2 squared minus 4 times my a value times my c value all over 2 times my a value. And recall from last year that we always pulled the square root off to the side and evaluated that first. So negative 2 squared gives me a 4 minus 4 times 3 is 12 times 4 is a 48. So I'm dealing with the square root of a negative 44, and I know I can break this up into a negative 4 and a root 11, so I get 2i root 11. So I'm going to take that and put that back in the problem. So I have x equals a positive 2 plus or minus 2i root 11 all over 6, and then we reduce our outside number. So all of these outside numbers can get cut in half. And notice again, you never touch the under part of the radical because that just remains the same. And now we've solved using quadratic formula. So yesterday we did some simplifying of problems that already look like that. Now you're going to get them on your own. So our next example is here we have this trinomial. You have x squared minus 2x plus 2, and I want you to evaluate it at 1 plus I. So everywhere I see x, I'm going to put a 1 plus I. So I have 1 plus I squared minus 2 times 1 plus I plus 2. And I know when something's squared, that means I write it twice. So when I FOIL, I'll get 1. My inner and outer will both be I, so I'll know that's going to be 2I. And then I'll get a plus I squared. And I know I squared is equal to a negative 1. So the 1 out here and this negative 1 are going to cancel, and I'm going to just get a 2i from that foiling. Then I'll have minus 2i, and that's coming from distributing up here. And then I plus 2. And notice that when I combine like terms, everything's going to cancel out, and I get the answer of 0. So that's it for that one. Let's go ahead and try the next example. And again, these are all kind of random. It's just we're at the end of the section, and these are a couple concepts I want to go over. So here I have 8 over the quantity of 1 plus 2 over I. So notice I need to handle this denominator. So I'm going to change this 1 to be 1 over 1, and then I'd multiply it top and bottom by I over I. So right now I'm at 8 over, and the whole point of getting those common denominators in the bottom is so that I can add them together. I plus 2 all over I. And now I want to keep change flip. So I'm doing 8 times I over I plus 2. So now I'm at 8I over I plus 2. And now we can introduce what we learned yesterday of multiplying by the conjugate. So I'm going to multiply top and bottom. I don't know why I wrote x there, it should be I. By an I minus 2. And we know whatever we do to the top, we need to do to the bottom. So when I distribute in the top, I'll get 8i squared minus 16i all over I squared plus 2i minus 2i minus 4. So I know these are going to cancel. I know my I squareds are -1 respectively. So in the numerator, I'm going to get -8 minus 16i. In the denominator, I'll get -5. And all three of these numbers cannot be reduced by the same thing, so I cannot go any farther. So last example, I'm going to read you a little blurb from the textbook, and then we're going to do the problem. So you don't need to write all this down right now. I'm going to read you a blurb, and then you can pause the video to copy this down. So the blurb in the book says, complex numbers are used in electronics to describe the current in an electric circuit. Ohm's law relates the current in the circuit I in amperes, the voltage of the circuit E in volts, and the resistance of the circuit R in ohms by the formula E equals IR. So notice I just kind of wrote it out for you. So E is your voltage, I is the current, and R is the resistance. And they want us to find the voltage of E if you're given I and R. So I'm just going to plug it into the formula. So my I value is 4 minus 5i, and the R is 3 plus 7i. And if I wanted to evaluate this, I'm going to FOIL it out or do the box. So I'll get 12 plus 28i minus 15i, and then minus 35i squared. And I know this will change to -1, so this is going to change to be plus 35. So a positive 35 plus 12 will be 47. And then I have to do 28 minus 15 to combine and figure out my imaginary unit. So I'll get 13i. And the units for this problem, since I'm finding E, is volts. So there's just kind of like a real world application. You might have seen this formula in one of your science classes. So that's all for today. That concludes the section 2.1, and we'll pick up with this material tomorrow.